Okay, so I'm going to start noting down the important information. Now, you can see that over here, I've got one box to note this because it's a boy on a bike. They're not connected by something that's under tension, which means I'm going to treat this mass as one thing. So 80 kilograms is the mass. Now, a slope of 1 in 5, if you look at the cheat sheet, it says that a slope of 1 in 5 really means that sine theta is equal to 1 over 5. If the resistance to the motion is 1/4 of the weight force, which is Wg, so in this case it'll be 80 multiplied by, or we'll just leave it as 80G at the moment. Calculate the tractive force in the tyres when he ascends with an acceleration of 2 meters per second. Now this is a lot of information, but really it's not any harder than what we're used to. Okay, so first thing I'm going to do is I'm going to resolve this force and this force. Okay, we know what this one is. That one there, if I punch it into the calculator, 1/4 multiplied by 80, oh, it's 20, times 9.8. So the force going in this direction is 196 newtons. We don't know what the force going up in that direction is. So let's get cracking. So in our downwards direction, we have got, now if I take this angle in here, so we're going to work out the angle next. Theta equals sine inverse 1 of 1 in 5, which equals, now if you don't get the same answer, check what mode your calculator is in. So it should be 11.53. Okay, so over here, this angle in here is 11.53, which makes this our adjacent side, which is why this one is cos. So that is going to be 80 times 9.8 cos of 11.53. 80 times 9.8 cos of 11.53. So that gives me 768 newtons. Now in the downwards, in the other force, we have got sine of that same ratio. So that's 156.7, we'll just round it up, 157 newtons. Now this is different to the way that the textbook does it because the textbook tries to make their life a lot harder than it needs to be. Okay, so let's start resolving some forces. So this is force equals mass by acceleration. Now we've got that our acceleration is moving in this direction. So that means our mass is 80 multiplied by 2. And now we're looking at the acceleration going in this direction, which means that I'm going to be adding together this force and this force and this force. Okay, I don't care about what's happening up and down. I only care about these three. Now the acceleration is going in the positive direction, but normally, you know, I just take the acceleration. If it's negative, I make it negative, and then I relate the rest of the diagram. So here we go. F, still positive, minus 196 newtons minus 157 newtons. So F is going to be equal to -353, and that's 160. So now I'm going to grab this guy, take him over to the side. So force is equal to 160 plus that is 513 newtons. So that is the tractive force.